All right, so in this particular limiting reactant example, you have calcium carbonate reacting with hydrochloric acid to produce calcium chloride, carbon dioxide, and water. So the problem essentially gives us two values to start with, 68.1 grams of calcium carbonate, and then it's going to react with 51.6 grams of hydrochloric acid. Now, this one's a little different. It asks you for the number of grams of carbon dioxide that'll be produced. So if you look at the reaction here, which is already balanced for you, so you don't have to worry about that particular part for this one. So you have your two reactants on the left side. I color coded here in orange and blue. And the question concerns us with carbon dioxide, which is in green. So as usual, I'll go ahead and block out stuff that I really don't need just to keep it clean and keep you focused there. Okay. So as the previous examples for limiting reactant, first you want to take the grams of the substances that are given, aka reactants, and you want to figure out how many moles of each you have. So from there, you can figure out which is the limiting or excess reagent, and then proceed from there. Okay. So the first thing you should do is start with one of the substances given to you. In this case, I just started with calcium carbonate. Again, you can start with hydrochloric acid if you like, but in the reaction here, calcium carbonate is on the left side, so I'll go ahead and start with that. So I'm going to take 68.1 grams of solid calcium carbonate, which is my starting point there. And then I'll go ahead and convert grams of calcium carbonate to moles of calcium carbonate, because once I know moles of calcium carbonate, then I can do mole to mole ratio. All right, so the setup is pretty standard. Grams of calcium carbonate on the top, that is your starting point. And then for molar mass, make sure you put grams in this case on the bottom because you need the units to cancel out. Okay, so calcium carbonate, it's going to cancel out with that. And that will leave us with just moles of calcium carbonate as our ending unit. So if you do calculator work, 68.1 divided by 100.09, you should get about 0.68 moles of calcium carbonate. Now, the next thing we want to do is go ahead and use the mole that we just found and use mole to mole ratio, because knowing 1 mole of a reactant, you can dictate or predict how many moles you need for the next reactant. All right, so I'm going to go ahead and use the value I got in the previous step, which is 0.68 moles of calcium carbonate. I'll carry that down in my second line of work there. And then from here, we do mole to mole though. Okay, so do not do molar mass. We do mole to mole. So mole of calcium carbonate and then moles of hydrochloric acid, because those are the two reactants that we were given to start with. So moles of calcium carbonate is a 1. The coefficient comes from the balancing reaction there. There is no coefficient in front of calcium carbonate, so that is a 1. And then in front of hydrochloric acid for this particular reaction, the coefficient is a 2. So we just carry those values down, pretty straightforward. And then most of calcium carbonate is going to cancel out. Numerator, denominator is going to cancel out. So for this one, the denominator is just 1 times 1, which is just 1. And then we just multiply 0.68 times 2. So if you punch that in your calculator, you should get 1.36 moles of hydrochloric acid. Now from here, though, we have to figure out grams of hydrochloric acid, because in the original problem, it gives us grams of hydrochloric acid. So we got to figure out whether this is enough or not enough. Okay, so let's go ahead and convert 1.36 moles of hydrochloric acid into grams of itself. So in this case, we're going to go from moles to mass. So carry the previous answer down to the next step, which is 1.36 moles of hydrochloric acid. We put that over 1 mole because now you're doing molar mass. So you really don't need to look at the balance reaction here. So just 1 mole of hydrochloric acid. The molar mass of hydrochloric acid is going to be 36.5 grams. And the units for moles will cancel out. And it leaves us with about 49.6 grams of hydrochloric acid. Okay. But then this is where the thinking part needs to come in. You just found that for every 68.1 grams of calcium carbonate, you need 49.6 grams of hydrochloric acid. But if you read the problem, though, it gives you 51.6 grams of hydrochloric acid. So without overcomplicating it, this is how much you need, which is 49.6 grams of hydrochloric acid. But the problem gives you more than what you need. So in this case, since you have more than what you need, hydrochloric acid is your excess. Okay. So anytime you're given more than what you need, that is extra, quote unquote, excess. Well, if hydrochloric acid is the excess reagent, which is in the reaction here, if this is excess, then by deduction or by default, calcium carbonate needs to be your limiting reagent. Okay. So in this case, calcium carbonate is our limiting reagent. And then to really find the number of grams of carbon dioxide that's produced on the right side of the equation, we need to use the limiting reagent. This is why it's important to do this step right, because if you do the step wrong in the last step, you'll get your values mixed up. So it's important to get and decipher which is your limiting reagent, because the next step, you need to use limiting reagent. The items that you're short of or don't have enough of will dictate how much product is produced. Okay. All right. So I made a note here using the limiting reactant, which in this case is calcium carbonate. And then we would just use the value of moles of calcium carbonate, because that's how much is given, to us. So start with 0.6 moles of calcium carbonate, put that over our 𝐶𝑎𝐶1. From here, we would just do mole to mole ratio, because the balance equation tells us that for every 1 mole of calcium carbonate, where my cursor is at the top, if you go to the right side of the product, the coefficient in front of this balance reaction as well for carbon dioxide is just a coefficient of 1. So it's a 1-to-1 ratio. So moles of calcium carbonate is going to cancel out. The 1-to-1, again, those two values, coefficients, come from the balance reaction. In this case, it just happens to be 1 and 1, which is nice. And then here we are. If you set up your stoichiometry correctly, moles of carbon dioxide and moles of carbon dioxide will cancel out, which will leave us just with grams of carbon dioxide, which is ultimately what the question is asking for. It asks again, what number of grams of CO2 will be produced. So we're pretty much done here. So you would just have to do calculator work. 0.68 times 1 times 44.0 divided by 1. In the denominator, you have 3 1s, so that's just multiplied to give you a 1. So if you do that correctly, the answer should be about 29.9 grams of carbon dioxide. Okay, so that's how much carbon dioxide would be produced if you were to mix 68.1 grams of calcium carbonate and 51.6 grams of hydrochloric acid. So you need to do limiting, and you need to identify the limiting reagent properly, because you need it in order to figure out how much product is produced on the right side of the function. All right. Other than that, I hope that helps. Okay. All right. Stay nerdy. Don't be whack.